Hello guys, in this video we will play with some primes in Visual Studio Code with Python language. So the first task we will do two tasks in this video. The first one will be spotting prime numbers from a certain range. We will look at range of 1 to 100. So first we need to know how can we find prime numbers. As we already know, prime numbers are the numbers that can be only divided by themselves and by 1. So all the numbers that divide by other numbers and their amount is 0 means that they are not prime number. So we need to make a loop which shows us which numbers are divisible by other numbers. We will remove those numbers from the list and we will remain with only prime numbers, and it will give us the number of how many prime numbers are in that list. So let's start with giving a variable count which is equals to 0 because we want to start adding from 0 forward. After that, we create a loop for I in a range of, let's say we need from 2 to 101 because we want to include 102. However, 1 is not a prime. I mean, it's prime, but it doesn't count because it's 1. So we give another variable is prime equals to true. We will see why we need that. After that, we create another loop inside of our loop which called I. We call it for j in range of 2 to I. Range of 2 to I. After that, as we said, if I, which is here in this range, from 2 to I, which we wherever it is has if we divide I by j, which means that from here, from this list from 2 to 101, if we divide it by j from 2 to whatever, from 2 to this line, and we get 0, it means that is prime. Our variable here is equals to false, meaning it's not prime. Yeah. However, if we spot the prime, if is prime true, if is prime true, then of course we go one more number after that one. And we print the count. So we have count 0, we're counting from 0. Then we have the I in the range of 2 to 101 because we need to spot the prime from 2 to 101. After that, we are saying that in the range of 2 to I, which I is this range, get every I and divide it by the j, and if the remainder is 0, then it's not prime, it's false. However, if it's prime, if it's true, like if as we showed here, add one more and count them until we find the final one, until we reach 100. So if we run this code, we should get 25, meaning there are 25 prime numbers. So let's show here, as you remember from early videos, the Euclid's theorem that there are infinite prime numbers. Let's try to show it by direct proof, just taking some primes in a certain list, then showing that there can also be another prime if we add one to it. So let's say that we have a list of primes equals to, list is, let's say 2, 3, 5, and 7. We can add it up as long as you want, but they should all be prime here. So when we saw with sum the count was 0, here the count is 1. It starts from 1 because it's a product. With 0 we can't do any counting because anything multiplied to 0 will be 0. So let's make a loop for num in primes. which is our list here, make the product times equal to num, which means that the product, when we are finding the product of these primes in the list, and this gives us another prime. So the new prime that we get after multiplying all of those in the list will be equal to product plus 1, which means we go one more number ahead. Let me say print the new number, yeah, new prime, my bad, new prime, yeah. So if you run it, we should get 211, which is prime again. So we just proved that even if we have the list of all the primes here and we add 1 to it, to their product, we will get a new prime. That's how Euclid also proves that they are infinitely prime numbers from, for example, if you have the product of certain prime numbers and we take their product and add 1 to it, we will get a prime which is not in the list that we had, meaning that we have one more new product, which proves that the prime numbers are infinite. So this was the easy way to kind of play with prime numbers and show uh, how they work or spot them in a certain range. Yeah, this is it for this video.